Thank you, Erica. And it's good to be here. Nice to be invited by Geoslope and Seequent to speak to you. I did this a few weeks back in Lima. And I just want to assure both Geoslope and Seequent, I'm not an employee of either one of those companies. And so whatever I say today is not binding on either one of them. Okay, so it's a bit of a caveat. You can see from my title slide that I've taken unauthorized use of the tagline for Seequent, that complexity to clarity, and added on imagination. And so with this merger between Geoslope and Seequent, this is my dream, if you will, that we'll move from data complexity to clarity and seamlessly move to imagination. Now, I didn't put this picture of me up there so you could see that I'm wearing the same shirt as I had when I took the picture. Just for the record, check out Nick Fogarty. He's got the same jacket he had on in Lima. Like, he only has one. In rhetorical theory, there are three fundamental Greek words: ethos, pathos, and logos. Logos, of course, is the argument, the story I'm trying to convince you of. Pathos is my ability to connect with you, which is a little tough because of the lights, and I don't know where you come from. But ethos is who the speaker is, and why who the speaker is connected to the story and to the audience. And so I just wanted to show this because what it highlights, very briefly, is in my 35, 40-year career, I've had this schizophrenia. I was trained as a civil geotechnical engineer, but entered environmental world as a researcher and as a consultant. And as I worked with mining companies across the globe and with consultants, I lived with this challenge all the time, much like Dr. Hodge talked about, is that the data was siloed. The analysis were siloed. The people you talked to about the geotechnical challenge were not the people you talked to about the environmental challenge. So that ethos, that experience, that schizophrenia kind of shows up in my talk, and I think this helps you understand why it shows up there. Now, many of you know Seequent. You were invited here by your friends, but you may not know Geoslope. So I throw up the Geoslope mission statement. Like all mission statements, it speaks as much to who we want to become as it does who we are. But in there, you'll see some key operative phrases or words. Integrated. We really strive to integrate across different types of physics, but also in data flow and workflow between outside and inside work use of the analysis. We want to make sure there's an integration in terms of that data flow pathway. We're not simply geotechnical engineers. We're trying to offer up a multidisciplinary solution to engineers and geoscientists, and we really strive to make our analysis numerically and mathematically rigorous. Now, if you know us at all, and I don't want to do a survey, I don't want to embarrass myself, you probably know us for slope stability, Geoslope. That's sort of a legacy name that we've had for dating back some 40 years. Slope stability has been our raison d'etre. But you may have also encountered that we do groundwater flow and stress-strain behavior and dynamics analysis. Probably even few of you know that we do airflow and water flow and contaminant transport and gas migration and geothermal problems. That's who we are. And for nearly 40 years, we have thousands of clients in 120 countries around the globe, and they use our software to deal with their challenges in the civil engineering, geotechnical, hydrology, environmental, geothermal space. That's who Geoslope is. And this is Seequent and Geoslope now working together. And this is where I get excited about the possibilities. That you have a firm that, as Dr. Hodge pointed out, has focused on taking data complexity and bringing clarity and communication to it. And what we're hoping is now we can merge that with a company that's focus has been on analysis. But let's go back to this question of, why did I say imagination? And it's because this is what I've taught for nearly 40 years, that imagination is numerical analysis. It is numerical simulation. I've taught my students for 40 years that the reason you use a numerical model to predict groundwater flow or slope stability is not to predict. It is to see the earth processes come alive. Webster's definition of imagination is to form a mental image. And when you have this data sorted out and you're saying, is that pit slope stable? Will I have problems with inflows into this pit? What you're trying to do is imagine. But why not use a tool to imagine? And so numerical modeling, ultimately, we do have to make predictions. But we should be humble about those predictions and transparent about those predictions. But most of what you do with a numerical model is you daydream. You say, if that is my hydrogeology, if that's my structural geology, if those are my soil properties, I wonder what my factor of safety is against slope instability. If those are my hydraulic conductivities and my geology of my aquifer-aquitard system, what's the rate of the inflows and where will I get overpressurization? You can wonder that all day unless you can dream it, unless you can see it. You can't design it or mitigate it or communicate it. Now, I'm going to talk to you about this dream, but I just want to lay out a couple of big caveats here. And I'm going to draw upon my soft side, arts and science side, to give you two quotes. English poet Robert Browning said, "A man's reach should exceed his grasp, or what's a heaven for?" You're going to see today, I am reaching far beyond my grasp. What I'm dreaming about, we don't have yet. But this is my hope. The British chemist Douglas Everett said, there are some people who live in a dream world. That would be me. There are some people who live in reality. That would be you. And then there are some people who take one and turn it into the other. And that's my hope for this new marriage, if you will, between Seequent and Geoslope. Okay, let's talk about this dream. I'm going to invite you into this imagination story. I want you to start a journey in geotechnical imagination. And so I've described the geotechnical imagination story in two parts. You can dream in black and white. Thousands of our users all over the world dream in black and white. What does that mean? It means that you're only interested in slope stability. You're only interested in hydrogeology and groundwater flow. You're only interested in stress-strain behavior. And so you imagine these physics at work on your site with your geology, with your data. That's great. Dreaming in black and white can be great dreams. But what I want to show you is that the whole point of GeoStudio, which is the software package, is that you can dream in color. You don't have to just dream about slope stability. You can dream about slope stability and hydrogeology and stress-strain behavior, and you can connect all these pieces together. You can dream in multiple geometries, 1D, 2D, 3D. You can dream in multiple dimensions as well as multiple geometries, different cross-sections, different slope angles. And then I'm going to push you a little farther. And I was glad to have Dr. Hodge in front of me because this was his push as well, is you already have this data. You already have your site characterized. You've already done your geotechnical analysis. So just push the dream one more step farther and start dreaming and using your environmental imagination. Start closing water balance and look at how much water is moving through your spoil piles. And try to imagine what kinds of rates of chemical loading are coming out of your dumps and how you're going to mitigate those issues. It's not separate data in different silos with different people and with different analysis. This is all sitting at your site. It's comprehensively the one ecosystem you've got to live with throughout your planning process and that long history that Dr. Hodge talked about. So for example, this dreaming in black and white you can do right now. You've got a leapfrog model and you've got your geology in there. And you go into your leapfrog model and you extract all your properties and your different lithologies, and then you drop a cross-section. You pull the cross-section out and you run a slope stability analysis. That's dreaming in black and white. You can look at the factors of safety and the controls of the material strengths, the geometries. But the pore pressures here, you just made up. You just drew in a piezometric line and said, maybe it's going to look like that. Right across the office from you is your hydrogeology friend. They don't care a twit about slope stability, but they're really curious about how much water is recharging into the natural ground around the watershed that you're working in. They're interested in sort of how that water is reporting to the pit and what kind of pumping rates and where should they put in their dewatering points. They're dreaming in hydrogeology and you're dreaming in slope stability. What you don't realize is that when they run the hydrogeology model, they're actually telling you a lot about pore pressures. And those pore pressures go straight into your slope stability model. And now your dream goes from black and white to color. You're now bringing multiple sets of physics that interrelate, and you're trying to imagine what they look like together. It's a richer dream. It's a more vibrant dream. And it helps you identify more critical elements that either you can be aware of or monitor or mitigate or control. I wouldn't necessarily propose this for all of you, but you can even dream a little bigger dream in color. You could say, you know, I'd like to follow the stress history at my site. I'd like to excavate my pit. I'd like to let those stresses relax. I'd like to force that rock into yielding. I'd like to then couple that with a changing temporal hydrogeologic system and then look at how my factors of safety evolve. You can then dream with groundwater flow and slope stability and stress analysis. So that's dreaming now in color. We've just recently, the last few months, started to dream in groundwater flow in 3 dimensions. And in fact, I think this week we actually released geothermal analysis in 3 dimensions. So now you can actually see a little richer dream, another multi-dimension dream. But in the same way, you can pull from this multi-dimensional dream, maybe pore pressures through a levee or a dike. You can pull those back into a cross-section of slope stability. And now you're getting a richer dream, both in terms of dimensionality, 3D to 2D. Now that dream, I suspect many of you are geological engineering background, geotechnical background. You've had those dreams, both black and white and color. And I know I'm preaching to the converted here, but now I'm pushing you saying, but you know, you already have that data. You already have those analyses. You already have characterized your site. So now push that dream into a dream about closure and site-wide water balance and what kind of effluent release is going to come out of your dumps. And what is the pathway for that, groundwater, surface water, and how are you going to mitigate that? Can you use a saturated backfill? Do you have to pump and treat? You can build on the previous dream. You don't have to start a new dream. This is an artist rendering of a site that I've been working on both as researcher and consultant for many years. It's a 30-year-old plus spoil pile laid up into a valley. Spoil pile, obviously, because it's got blast-derived nitrate in it, leaches nitrate out of it. It also oxidizes, and it's pyrite-rich, so it creates a lot of sulfate and metal release. And so if you look at this problem and say, what would I like to know about this problem? Well, I need to close a water balance. I need to know how much water is moving through the dump. I need to know something about how gas and water are moving through the dump because oxygen starts to come into that dump. It's going to get consumed. It's going to generate the sulfate, the metal loading, and then the water movement's going to flush that from the dump along with blast-derived nitrate that's present in the dump. I need to see those processes at work. And then ultimately, whatever passes through the dump, so we report to the rock drain or into the groundwater system, and I'll have to figure out a way to either anticipate that loading, define whether it's going to be detrimental, what's my environmental efficiency, not just my economic efficiency, and then figure out a treatment strategy. So this is the kinds of dreams that we've been dreaming with the kinds of products that GeoStudio offers. We just do a one-dimensional water balance of the site. Now you say, well, one dimension, how good is one dimension? Well, the nice thing about one dimension is you can take very rich data sets of meteorological data, wind speed, radiation, air temperature, relative humidity. You can use that to calculate climate demand for water. You can combine that with whatever your reclamation strategy is. What are we going to plant? How thick is our cover going to be? Now you can start to predict the water balance dynamics on a daily and an annual and a decadal cycle, looking not only operationally but into the future. And now you'll be able to start to visualize how much water is moving through our dump on an annual basis. What's the time delay in that water pushing out solutes, chemicals of concern to finally some receptor that I need to be accountable for. We did this at this particular site, and we thought, well, it was quite a bold dream, but why don't we take our site? We now have some sense of what the water flow through the dump is historically. The piece we're missing is what has happened to the dump in terms of chronology. So we took a very simple approach. We built a cookie cutter, if you will, and dropped 21 one-dimensional models down through that dump area to give us a picture of the evolution of the dump with time. Now, just as a sidebar here, I have worked on many sites with many consultants and with many industry people, both in research and consulting. And this piece of data is the hardest piece of data to find anywhere. Dump chronology. You wouldn't build this building without drawings. You wouldn't build anything without as-builts. And for crying out loud, start building an as-built of your mine waste and your dumps and your tailings facilities. Hopefully some of you are. So using this, the two pieces, climate-driven flow through the dump, we took and added a geochemical source term to this, nitrate as a conservative species and sulfate as a produced species from oxygen. And we just closed our eyes and we pushed the button and we got this. The bottom is the nitrate and the sulfate concentrations with time, predicted as the green line, measured for base flow, winter base flow, kind of gives us the best concentration measurement, is measured as the dots. And the top is the cumulative load. This doesn't happen often with models, okay? But sometimes you dream big and you start to see patterns that you can start to bring understanding, some confidence, and some anticipation of what you're going to have to deal with 10, 20, 50, or 100 years out. Now, you may think of me as a bit of a crazy old professor. I fully accept that judgment. I am. But Mike O'Kane was one of my first students in mining research many, many, many years ago. Mike's an old man now. But Mike has developed a company that works all over the world, and he's a dreamer, and he's a leader in exactly these kinds of questions I'm just posing to you, this journey I'm asking you to think about stepping onto. So I want you to listen to Mike's pitch.
We've been around for about 25 years, and we're quite proud of being from Saskatchewan and working around the world in our little niche area of optimizing mine waste management in the mining industry. What we do, which is optimizing mine waste management and developing cover systems and landform designs and working with our clients to build better mine rock stockpiles to manage long-term water quality. Probably 75–80% of the liability to surface water and groundwater receptors comes from mine rock stockpiles. And so trying to quantify that and minimize the risk of unfunded and unrecognized liability for a particular mine site is, it's a big challenge to try and say, what can we do now that's better so we don't have to deal with that risk later? You know, mine rock stockpiles can be billions of tons of rock, billions of cubic meters. Some material can be very reactive and temperatures can increase, and you can actually have spontaneous combustion and self-heating of rock because they're so reactive and it's drawing in so much additional oxygen from the atmosphere. So we can actually show that on a large scale using the Seequent data communication tools. And then we use the GeoStudio software in order to be able to quantify how much of that is happening. The GeoStudio software allows us to quantify that and then quantify the benefits in terms of stored acidity and water quality when we say, what if you built it so you didn't have as much advective gas transport capacity and airflow capacity? Now we can quantify that on a quite detailed basis. So the numerical modeling allows us to present that. So for example, let's talk about cover systems, right? So the GeoSlope software is a really valuable tool for us to be able to take a conceptualization of, say for example, somebody needs to have 5% net percolation for a cover system to manage water quality. And now we can use the GeoStudio software to quantify that and say, what's the probability of getting to that 5% number for any given year? We can actually take the output from those robust numerical models that have the right physical, chemical, and biological processes in them, apply the site-specific controls within the model, and then take out what is the probability of meeting those. You can imagine a mine rock stockpile that's constructed into a valley we can take and run temperature scenarios, air quality, airflow scenarios, seepage analysis, and deformation analysis all in one. I mean, that's very powerful. The modeling tools we have now that's offered by Seequent and the visualization and the GeoStudio products, now they allow us to quantify that, to support that conceptualization. So it's not just being the loudest person in the room and convincing the right person in the room. It's actually, people can see the results, they can quantify them, and they can see if I spend this many more dollars per ton or this many more dollars per ounce of gold produced, that I actually do get benefit of that. I can quantify that much sooner and be able to then communicate that to shareholders, to management. Because this is why we're spending a little bit of money now, because it actually manages risk in a much more effective and sustainable way in the future.
This is the question Mike has. I can build the dump that way or I can build it this way. But without being able to imagine, unless you can put this to some way of seeing the physics at work, how do you quantify both the cost and the environmental consequence of those two alternatives? Quite a simple case. So Mike was showing you these two examples. Where end dumping, you allow oxygen in, you get heating, exothermic release of heat, you end up with convective airflow, and so every year there's an annual cycle that's deep-seated oxygen ingress into your dump and accelerated oxidation. Changing the dump configuration to a bottom-up in this particular case, you end up with localized flow systems and limited oxygen ingress, and by the time you get to the end of the dump placement, you've isolated most of the waste rock from oxygen. A simple comparison, but without the ability to imagine, how do you make a decision? Now, you've been very patient. Let me prompt you to press your geotechnical and your environmental imagination. But what I'm really after today, and remember, I don't work for either company, is I'm really pressing you to think about what are you doing with your data and your analysis. And the silo word was used in the previous presentation. My experience at many of the sites that I've worked with is that these boxes of geological assessment of the ore, geotechnical assessment of mine operations, dumps and pits, and environmental assessment, all that data tends to live in separate boxes managed by different gatekeepers, and it's almost impossible to integrate or learn from. And I think the little I have learned of Seequent in the last few months, this is what they're doing. They're helping you put all those boxes into a single place where you can bring complexity to clarity and communicate that data in an effective way. That requires integration. And this is why I think GeoSlope is a great partner, because we bring geotechnical assessment and environmental assessment tools to bear. We're trying our best to make sure that these are multi-physics and seamless and integrated. But the real win here is this one, is the ability now on interoperability to share both data streams and analysis streams and keep them all within the same ecosystem. Now that's a dream. Remember my caveats from my two poets here. We've got a long ways to go. And if this is a journey that sort of excites you as it excites me, this is a journey definitely we want to take with you. Now I couldn't think about imagination without one last cheesy quote, but it's because I'm old. It's this one. I hope someday you will also see this as a dream and that you will join us and help us to imagine maybe in a new way. Thank you very much for your patience.